Find the volume of the solid formed by rotating the region enclosed by these graphs. Y equals root of x plus 1. X-axis, y-axis. And x equals 4. About the x-axis, okay? Let's look at that zone. Here is the square root of x plus 1. Go a little bit further than that. Here's the x-axis and y-axis right here. And then here's the line x equals 4. So here's the area in question. This is not washer. If you do use washer, your inside radius is 0. So knock yourself out there. Around the x-axis, the volume is going to be relatively straightforward. Pi r squared. Okay. The radius is the distance from here to there, which is just the function value given to you. Starting and stopping points, because of the x-axis, y-axis, and the line x equals 4, we're going to go from 0 to 4. So if you type that in your calculator, you get the right answer, whatever that is. If you do it by hand, this is another one you could have gotten the bonus point by doing it by hand. All right, let's leave the pi there. The first thing I would do is go ahead and square this out. So this is going to be x plus 2 root of x plus 1, which is going to give us pi. All right, let's see here. That's 1/2 x squared. Okay, that is x to the 1/2. Raise the power 1, you will get x to the 3/2. Then multiply by the reciprocal, and take that 2/3 and partner it up with the 2 and get 4/3. And then the antiderivative of 1 is x from 0 to 4. Kind enough to give me a 0. I do love that. This one, I don't remember where I pulled it, but it has a very non-calculator feel to it because they're giving you the 0 and they're giving you a disk. This would have almost surely shown up on a non-calculator part of the test. Okay, let's stick in 4. We're going to get 4 squared is 16, half that is 8. Square root of 4 is 2, 2 cubed is 8, so that's 32 thirds. And then a 4 here, stick in 0, we get 0. Okay, 8 and 4 is 12. 12 as a third is 36 over 3. 36 over 3 and 32, I think, makes 68. So 68 pi thirds. The decimal equivalent is 71.2094. Okay. Again, one of those places that you could have earned, I won't say an easy one, but a moderately not difficult extra point for that one. Oh, Lord. Now 7, nobody fell into the, I thought y'all would butcher this one because of the way I had it worded, but I think y'all just ignored it anyway. You got kind of lucky.
No, because you told us about this before, I believe.
Yeah, if you were paying attention, I had mentioned it, so I'm glad somebody listened.
What are we talking about?
You'll see. Find the volume of the solid formed by rotating this graph. And I tried to pick one that was going to be familiar. This is one of the equations that showed up on the group test, just not this particular cut, okay? But it showed up on the group test. And we're rotating this about the x-axis. Okay. Now, the zone itself is going to look like this. Let's see. Okay, the y's will go up here, the x's will do that. If you were to graph this one, this is what you get. Okay, here's where I was trying to fool some people, and really either nobody fell for it or y'all got lucky because you didn't do this. All right. If you were to treat the entire area like it was spun, you would actually get twice the volume. Here's why. Okay, look at the top half of that. If I were to take just the top half and spin it, I would get the exact same shape as if I had taken the bottom half and spun it, right? Volume-wise. So if you were to spin both of them, the whole shape itself, you would get too much volume. You'd be counting the same shape twice. So what you really need to do was just look at one piece of it. If we spin the top half, we get the exact same volume once as if we had spun top and bottom half together. If we were to solve this for y, we get 4 minus x squared over 4, then we take the square root of that. And it is technically plus or minus, but because I only care about the top part of this graph, it's gonna do the job, we'll just stop there. Right? With an understanding that yes, I need a plus minus normally, but this setup is not. So, and it is disk, it's not even washer, it's disk on this one too. So the volume is going to be pi r squared. You have two choices with the interval. Because of the symmetry, you could go from -2 to 2, or you could go from 0 to 2 and double it. Makes a difference. I'll write it as -2 to 2. I am going to do this though. Notice that these two are the same thing, we just took half the distance. Don't let this confuse you with shell, because it's not a shell setup, right? The nice thing about this is that the radical gets knocked out, so we end up with 4 minus x squared over 4 dx, the square of the square root, and this 4 can be yanked outside to give us pi 0 to 2 of 4 minus x squared. And if you still had your quiz from the day before, we had already worked that one out. Or you could redo it here. So let's see, pi 4x minus 1/3 x cubed from 0 to 2. You hang tight pi 2's, that's going to give us, stick it 2, we're going to get minus 8/3 minus 0. All right, that is 24/3 minus 8/3 is 16/3, I think, 16/3. 16 and 2 cancel each other out, and I think it's 8 pi thirds. Check my notes, but I think it's 8 pi thirds. Yep, 8 pi thirds, which is something in the just saw it, 3775 range. Dot, 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 dot. Okay. Please ask any follow-up questions you may have. This is the last I shall speak of the children.
Will you sign this? Okay.
All right, any questions on the quiz?
This is perfect.
Hope y'all took decent notes, made corrections. You know, so I give you the stuff back. Write notes to yourself. Don't do this again. Watch your intervals. Take half of the diameter. And write notes to yourself. All right. You, dear child, need to go ahead and take your test today.
Yeah, I know.
Okay. The rest of us, today or Monday?
I think it's Monday.
Monday,
Monday.
Monday, Monday. Okay. And then I'm gonna give you two the option, although I think you're gonna pick Monday, so the test will be waiting for you on Monday. Okay, that's it. Oh, work on your quest, that's what you need to do, study and work on quests. There you go.
What time does third